Have you ever looked up at the night sky and wondered where it all came from? That question has captivated humanity for millennia. We are a curious species, always seeking our ultimate origin story. Science has traced our cosmic history back billions of years to a single explosive moment, the Big Bang. The Big Bang is the starting line for everything we know. Every star, every galaxy, even us. But our curiosity pushes us further. What happened the Big Bang? What was there before time and space? For centuries, this was a question for philosophy or religion. But now, physics and mathematics are daring to peek behind the curtain. These new ideas challenge our understanding of reality, hinting at a story grander than we ever imagined. So, let's journey to the edge of what we know, exploring the frontiers of cosmology. We'll look at ideas that sound like science fiction, other universes, or a cosmos endlessly reborn. We may not find all the answers, but the quest itself is a testament to our unyielding desire to understand the cosmos. Join me as we explore the ultimate mystery, our cosmic beginnings. The search for what came before the Big Bang is just beginning. To ask what came before, we first need to understand the Big Bang itself. The Big Bang wasn't an explosion in space, it was the rapid expansion of space itself. Imagine all the energy and matter of our universe packed into a tiny, hot, dense point. About 13.8 billion years ago, this singularity began to expand, and space itself unfolded everywhere at once. As the universe expanded, it cooled, and energy transformed into the fundamental particles that make up everything. For hundreds of thousands of years, the universe was a hot, foggy soup where light couldn't travel freely. Eventually, atoms formed, the fog cleared, and light was set free. This is the cosmic microwave background, a fossil echo of the Big Bang. Gravity then pulled atoms together, forming stars, galaxies, and clusters. Inside stars, nuclear fusion forged the elements that make up our world. The Big Bang wasn't just a moment, it was the start of an ongoing process of cosmic creation and evolution. Every atom in your body traces its history back to that first moment. Our universe is the product of billions of years of cosmic change. Understanding the Big Bang is the first step in unraveling what might have come before. Now, let's look beyond that beginning. What if our Big Bang wasn't the only one? The multiverse theory suggests our universe is just one bubble in a vast cosmic ocean. Imagine a pot of boiling water. Each bubble is a universe expanding with its own physical laws. This idea comes from inflation theory, which proposes that the universe underwent a rapid growth spurt right after the Big Bang. Some versions suggest inflation is eternal, constantly spawning new bubble universes. Each bubble could have different physical constants, particles, or even dimensions. In this view, the Big Bang is just a local event, our bubble's beginning. The larger metaverse is always inflating, creating new universes. Some universes might be empty, others wildly different, and a few, like ours, just right for life. We can't visit other universes, but scientists search for indirect evidence, like patterns in the cosmic microwave background. The multiverse remains unproven, but it's a powerful idea that flows from our best theories. If true, our universe is just one of countless cosmic experiments. The multiverse could redefine our place in reality. The story of our origins might be far bigger than we ever imagined. Another idea comes from quantum mechanics, the science of the very small. In quantum physics, empty space isn't empty. It's a sea of energy where particles pop in and out of existence. What if our universe began as a quantum fluctuation, a random energetic blip in a timeless quantum vacuum? This nothing isn't true emptiness, but a state of pure potential. By chance, a fluctuation big enough could trigger inflation, creating a universe. The total energy of the universe might be zero, matter's positive energy balanced by gravity's negative energy. If so, a universe could emerge for free, no creator required. On the quantum level, things can pop into existence spontaneously. The Big Bang in this view was a natural, spontaneous event, one that could happen given the laws of physics. Our universe might be the ultimate free lunch, born from quantum possibility. What if the Big Bang wasn't the beginning, but just one event in an endless cycle? The cyclic universe model suggests our cosmos expands, contracts, and is reborn forever. Imagine After billions of years, expansion slows, reverses, and the universe collapses in a big crunch. Out of this collapse, a new Big Bang erupts, a big bounce. The universe is reborn, starting a new cycle of expansion and creation. In this view, there was no absolute beginning, just endless cycles of death and rebirth. Each cycle could produce a universe similar to ours, or something entirely new. This model avoids the problem of a singular beginning. However, current observations show our universe's expansion is accelerating, making a future collapse unlikely. Still, some physicists explore ways a cyclic cosmos could exist, even without a big crunch. The idea of a universe eternally reborn remains a tantalizing possibility. The story of the cosmos may be one of endless renewal. Why can't we just look back and see what happened before the Big Bang? Our knowledge comes from light and radiation traveling through space and time. The oldest light we can see is the cosmic microwave background, from when the universe was 380,000 years old. Before that, the universe was a hot, dense plasma, opaque to light. No light from before this era could reach us. It's like trying to see through a solid wall. The Big Bang itself is a point where our current physics breaks down. Einstein's relativity can't describe the singularity. Our equations stop making sense. We need a new theory, quantum gravity, to understand what happened at such extremes. Without it, we're explorers at the edge of the map, peering into the unknown. Theories like string theory and loop quantum gravity are promising, but the true story remains hidden. Breaking through this wall may one day reveal what came before the beginning. Maybe the question what happened before the Big Bang is flawed. The Big Bang wasn't just the start of matter and space, it was the beginning of time itself. Asking what came before is like asking what's north of the North Pole. The concept doesn't exist. Stephen Hawking suggested the universe has no boundary in time, no before. As you travel back, you reach a point where time itself vanishes. Time doesn't extend infinitely into the past. It begins at the Big Bang. This is hard to grasp. Our lives are built around the flow of time. But physics tells us time is a property of the universe, woven with space into space-time. If time began at the Big Bang, there was no period of waiting for the universe to start. The question of before may not apply at all. Other theories, like the multiverse or cyclic models, could still be true, but our understanding of time would be very different. The universe may have brought time into existence with itself. Exploring our cosmic origins helps us define our place in the universe. Each discovery has pushed us further from the center, Earth, the Sun, our galaxy, now perhaps even our universe. If the multiverse is real, our universe is just one bubble among countless others. This would be the ultimate Copernican revolution. We are not special, just part of a vast, mysterious reality. The atoms in your body were forged in ancient stars, born from the clouds left over from the Big Bang. We are, quite literally, made of stardust, children of the cosmos. Understanding the Big Bang and what came before is about tracing our deepest roots. When we look at the stars, we see our own history. The light we see is from the cosmic furnaces that created us. Pondering the Big Bang is contemplating the origin of the very fabric we inhabit. This perspective is humbling but also empowering. We are part of a grand cosmic drama. Our quest for origins connects us to the universe in a profound way. Why care about what happened 13.8 billion years ago? Because this quest is fundamental to who we are. Curiosity drives us to explore, invent, and imagine. The pursuit of cosmic questions has led to technologies that transform our world: GPS, computers, medical imaging. The tools we build to study the universe will spark innovations we can't yet imagine. But beyond technology, this quest enriches the human spirit, giving us wonder and perspective. Knowing our place in the cosmos can foster unity and humility. The search for our origins is a search for ourselves, an expression of our need for meaning. We are the universe's way of knowing itself. And so we keep asking, keep exploring, forever reaching for the unknown.